Cool. Let's get started. Good evening, everyone. Happy to see everyone here. I hope we're all having a great time here at GraphQL Conf. I know I'm having an amazing time here at San Francisco, other than my carry-on baggage getting stolen at the airport this morning. Unfortunate, but hey, you know, look at the bright side of things. At least we got great air quality here. Oh, wait, never mind. I had an amazing caprese baguette for lunch. There we go. That's a pretty good. Yeah, so I'm not going to be talking about caprese baguettes. I'm going to be talking about GraphQL with you guys here today. We're going to be sort of diving deep into a transformative approach that revolutionizes the way we can think about GraphQL. I say revolutionizes, but it's already being done here at this conference. It's being done in the industry, and that's declarative GraphQL. So I'm going to be talking about how you can supercharge GraphQL with declarative configuration. So whether you're a GraphQL enthusiast or just dipping your toes for the first time in GraphQL, I think this talk is perfect for you. So let's start on this journey together. Before we start, a little bit about me. I'm Sai Ekbote. I'm a principal engineer at Solo.io. I am deeply invested in GraphQL because I was one of the lead engineers on our GraphQL product at Solo, which I will be talking about further on in the presentation. Other than working on GraphQL and the related tech, I like to wrench on motorcycles, and I also really like birds. So you've probably seen Solo.io's booth outside and had a chance to talk to one of our wonderful booth staff. I see Jim's in the room here. We worked with some of the leading technologies in cloud networking to develop a platform of products that makes your application networking as easy, efficient, and powerful as possible. And part of that includes GraphQL. So Solo.io has recently invested in GraphQL because it recognizes the paradigm shift in the world of API development. As microservices and distributed architectures become the norm, there's an increasing demand for a flexible, efficient, and descriptive way to fetch data. GraphQL, unlike traditional REST APIs, offers clients the power to request exactly what they need, no more and no less, which I know we're all very familiar with, this being a GraphQL conference. But at the heart of our topic today is in how we approach the system of GraphQL and the design, declarative configuration. In the tech realm, declarative configuration is all about stating what you want and letting the system figure out the how. It simplifies processes, minimizes potential errors, and streamlines development. So let's look at some examples of declarative configuration. We deal with declarative configuration every day in the cloud environment. For example, Kubernetes YAML manifests allow us to describe the desired state of our application infrastructure without needing to detail every command or action to get there. Terraform lets us declare the desired state of our cloud resources. We might even want to specify certain things like number of virtual machines or a specific database setup. A little tidbit here, a little fun fact. Have any of you seen what the new name for the OpenTF project is? It's OpenTofu. Really interesting. And moving on, another example of declarative configuration or declarative pizza ordering. You don't really have to worry. You can click on, let's say, extra cheese without worrying about the story of the dairy cow that made that cheese. You get what you crave for and let the tech magic do the cheesy behind the work scene. So we can see that declarative configuration has clear advantages. Clarity in your definition, reducing boilerplate code, reducing the amount of work you need to do as a dev, and easier maintenance. But at a GraphQL conference, why am I talking about cloud technologies and declarative configuration? How could these possibly apply to GraphQL and what we're talking about today? Believe it or not, we already do GraphQL in a declarative fashion. So before I get into the actual meat of the subject, I'm going to be talking about what declarative GraphQL is, what it looks like, how it exists today in libraries and products, and how we can leverage it to do some really powerful stuff, and how we're currently doing that at Solo. The SDL, the schema definition language at GraphQL, already epitomizes the essence of what declarative configuration is. Instead of dictating how data is fetched or processed, developers simply define the structure of the data and the relationships of the data. By using SDL, GraphQL schemas communicate what the data looks like, letting underlying resolvers handle the how. It's a testament to how powerful declarative configuration can be and how easy it can be to read. But then we come to the resolvers. Now, resolvers are traditionally written as code. They can be verbose, twisty, and hard to read. And while detail can be enriching in some contexts, in the world of connecting APIs and application networking, it can often lead to confusion, inefficiencies, and a steeper learning curve. And when you factor in the fact that your implementation can be written in more than 15 different languages with more than 100 different GraphQL libraries, it can become a lot. Just look at all the code-based implementations for GraphQL servers. They all have their purposes, I understand, but I think that these can be simplified to a more declarative configuration. So let's simplify. Let's zero in on what this declarative configuration looks like. Rather than getting lost in every single detail of our resolvers, trying to read and deconstruct the code, we use a known framework to write our resolvers without getting too complicated. But before I dive into what the declarative configuration can actually look like, there's a lot of different ways that we can leverage it. And there are many different tools that do so. So I can think of GraphQL and resolvers and how you implement them as kind of being on a spectrum, from a super imperative approach to a declarative approach. And the imperative approach is something we're super familiar with in libraries like GraphQL Yoga, GraphQL Tools, GraphQL HTTP. These are libraries that we leverage whenever we want to write GraphQL servers and GraphQL applications. And then we move on to more sort of hybrid approaches like GraphQL Mesh, which allows us to leverage declarative configuration as well as some library code. And then we move on to fully declarative GraphQL products, such as Gloo GraphQL and StepZen. And when I was working on developing Gloo GraphQL, I did a lot of research on existing declarative GraphQL solutions. And these were, StepZen and GraphQL Mesh were some of the most prominent. So I will also be going over what those look like more specifically. Let's start off by looking at StepZen. StepZen is a platform in the GraphQL space designed to integrate various backends, be it REST, SOAP, or databases into a unified GraphQL endpoint. As we explore further, we'll assess its features, capabilities, and how it fits into the broader GraphQL landscape. So this is a GraphQL schema that StepZen enriches with directives. The intriguing part here is the REST directive attached to the GraphQL schema. With this directive, we're telling our system to make a post request to the specified endpoint whenever my query is executed. In essence, this is a simple yet effective way of integrating RESTful APIs into our GraphQL schema. By leveraging such directives, we can bridge the gap between traditional REST and GraphQL without reinventing our backend. And we could do this in declarative code. We could use the fetch API. We could use any multiple libraries for creating a post request or creating an HTTP request against a REST backend. But why not make that a lot simpler and just allow the underlying product to do that for us, and we just have to configure it. So another really cool thing that StepZen does, since it was written in Go, it allows for additional flexibility and dynamic creation of outgoing REST requests from the incoming client GraphQL request. What does this mean? We can take parameters from our incoming GraphQL request and template that and insert it into our outgoing REST request. So here we create a dynamic endpoint where we insert the ID from the GraphQL request into the outgoing REST request, as well as construct the body of the outgoing HTTP request from the incoming GraphQL request. Another thing that StepZen offers is that these GraphQL schemas that we just saw can be automatically generated from a CLI tool, where an OpenAPI JSON definition of your REST backend can be discovered and converted into a connected GraphQL schema definition. Moving on, we're going to talk about GraphQL Mesh, another really powerful library that we can use for declarative GraphQL. GraphQL Mesh also really shines as a versatile bridge, enabling non-GraphQL sources to be seamlessly integrated into a GraphQL endpoint. It transforms existing services, be it REST, gRPC, databases, SOAP, into GraphQL schemas. And you can do so declaratively. You can specify the endpoints for the non-GraphQL services in a mesh RC file. This will automatically generate your GraphQL schema and resolvers and present it as a GraphQL endpoint to your clients. You can also rename generated types in case you want to introduce a custom field name scheme to your generated GraphQL schema. GraphQL Mesh also allows for a declarative way to do schema stitching, which we are all very familiar with as it's been a huge topic at this conference, as it allows us to connect multiple subgraphs, whether they be existing GraphQL servers or non-GraphQL services, into a supergraph. And last but not least is Gloo GraphQL, which is part of Gloo platform, a platform for unified application networking for your APIs. Now, I will say kind of shamelessly that Gloo GraphQL is my favorite because, well, I worked on it. But not only that, I believe that it's also a really great contender in this market because it includes all the features that we mentioned previously that GraphQL Mesh and StepZen offer, as well as being specifically tailored for a cloud-native landscape. In this following section, we're going to focus on the Gloo GraphQL API and how it achieves all of this and more. Gloo GraphQL is really powerful because it does declarative GraphQL with Envoy. Envoy proxy is a network proxy which is super powerful and is used all over the industry as the de facto API gateway and service mesh proxy. Now let's talk about why and how we did this. So first, we have to visit how GraphQL is being done today in a lot of scenarios. It often exists as a separate service running by itself, handling your GraphQL requests. Now this is something that you deployed by using some sort of GraphQL library, GraphQL Yoga, Apollo GraphQL. And in order to keep up with rising traffic demands and correlated problems such as security, DDoS protection, rate limiting, and caching on your HTTP traffic, you'll often add a network proxy that acts as an API gateway. This is pretty standard. There's nothing fundamentally wrong with this approach, but we feel that there's a more efficient way to support GraphQL in an application architecture to simplify the lives of your application development teams and platform engineering teams alike. And so the next logical step is to combine the proxy and the GraphQL server. So the GraphQL server exists as part of the network proxy. And what does this do for us? Well, it completely eliminates the developmental and operational expense of maintaining a separate application deployment. In this scenario, we see that the network proxy exists as a standalone component from your existing services, so you're not rewriting your application code to leverage GraphQL. The network proxy is doing all the translation from GraphQL requests to REST, gRPC, SOAP requests that I was just talking about. In addition to eliminating the additional network hop from a GraphQL server to a network proxy or vice versa. And these GraphQL capabilities, when in a network proxy, are based on declarative configuration, just like the rest of your cloud-native infrastructure. So this is fully compatible with CI/CD and GitOps workflows. So Solo.io has been working with Envoy for a really long time, and we've already developed a lot of powerful features on top of Envoy, such as caching, rate limiting, external authentication, WAF. We have some really powerful technology that we're using with Envoy. And with a mere tweak in configuration, you can also include your GraphQL server as part of this stack within the same Envoy proxy. You've got authentication via external auth, rate limiting, and a GraphQL server all within your data plane path without ever introducing another deployment to your stack. But the question arises, how does a developer use a GraphQL proxy, such as Envoy, that's already compiled? You're not going and building Envoy and trying to compile a C++ proxy just to use your own GraphQL offering. Well, this is where declarative configuration comes in. Remember how I said we tell the proxy how to handle GraphQL? We tell the proxy what to do with GraphQL requests, not how to handle them? Well, that's what declarative configuration does for us. So here we have a Kubernetes resource definition, which is essentially just YAML, manifest that we apply to Kubernetes. This tells our network proxy, which reads these resource definitions, what to do with our GraphQL requests when it receives them. Here we have a GraphQL schema and a resolver resource, which is essentially just the declarative version of our imperative resolvers. We say on the query type, there's a field called getPlans. For the field getPlans, we want to create a REST resolver, and the outgoing request from our GraphQL request is going to look like this. It's going to have a method of get, and it's going to have a path, which is dynamically created from the GraphQL arguments. And then the destination is a Kubernetes service. And then there's a little bit of code at the end that's a JQ filter, and we're going to get into that. So that JQ filter, it answers a very specific question. You're connecting your GraphQL server to some pre-existing service that may or may not align with your GraphQL schema. So what if that service's response does not align with your GraphQL schema? What if you need to do some sort of data mangling, some sort of data transformation on your data from your upstream service that may not align with your GraphQL schema? Well, we could use code here, but I just said we're not using code because we're declarative configuration. In this specific scenario, we have a upstream response that's given back the ID of our response object as a key in the response, as a key in the JSON. GraphQL obviously doesn't like this because it likes named fields. All of its fields that it needs to know how to recognize need to be named. So what do we do here? We use this JQ at the bottom, that code at the bottom, which is essentially a JQ filter, to transform our data. Specifically, we use a filter that maps our keys and values into an array and then constructs a new object from it. Now, this may look pretty complicated, but with a few sentences, I can explain to you what this JQ filter is doing. All it's doing is constructing a new object from each of the existing objects in our upstream response and turning it into something our GraphQL schema can actually work with. So that's JQ. And now we're going to talk about how exactly we went about implementing on GraphQL in a C++ network proxy. There's not many C++ implementations of GraphQL out there, obviously, for the reasons I'm talking about. It's not very extensible. However, Envoy made this very easy for us, or relatively easy for us, because it has a concept of filter chains, or a concept of filters. Essentially, Envoy can run any number of TCP or HTTP filters on any request that comes to the proxy. These filters can do some sort of unit of arbitrary work on the HTTP request and can be arranged in an order for each request called a filter chain. This is how we can do things like rate limiting, authentication, DDoS protection, web application firewall, and caching, all in the same request path as GraphQL within the same proxy. Now, all we have to do is make an entire Envoy filter that handles the GraphQL part of the request handling. Well, that isn't a super easy task. But the good news is we did that hard work already. So all you have to do is write the declarative configuration. And using this, we can just instantly turn your existing services into a GraphQL server. Now, another added benefit of declarative configuration is that you can use it with Git. You can use it with your GitOps workflow. GitOps essentially means that you check in your declarative configuration into a Git repository and use a tool like Argo or FluxCD to automatically deploy that configuration to your running clusters. So this means your GraphQL declarative configuration is maintained in a manner that's versioned, that you can easily reproduce bugs, you can roll back to previous GraphQL configurations. And so, wrapping up, here's some key takeaways that I want you to have in mind. So, declarative GraphQL is not just a trend, it's a paradigm shift. You can choose declarative configuration if you want your developers to have an easier time when adopting GraphQL. You can explore tools like Gloo GraphQL, GraphQL Mesh, and StepZen to harness the power of declarative configuration. And declarative configuration allows for clearer, more maintainable APIs. And another thing is with declarative configuration, since we're using things like compiled proxies rather than scripted programs, you can pay attention to the performance and scalability benefits when implementing declarative GraphQL systems. So that's all I have for today. I would love for any questions.
If you do have any questions, there's a mic at the table here.
Yes. Sorry, besides JQ, do we support any other sorts of transformations? Yeah, so because of the extensible nature of Envoy, we did do an evaluation of what other sort of transformations we could support. For example, Inja transformations, which is another very popular transformation language or templating language. However, we felt that JQ really fit the task here at hand, which was to transform your JSON data into other JSON data, or to transform existing data into other existing data. And so it was a very powerful and very efficient library that we chose to use. But if you did want to use any other transformations, for example, Inja, it's just a matter of plugging that in and into our existing model.
So I guess declarative tools, low-code tools, no-code tools are awesome when they work, right? And then you bang your head against the wall when they don't work really hard, unless there's an escape hatch, some way of writing Turing complete code. Is there an escape hatch?
So that's a really good question. And I think JQ was our sort of way of introducing the flexibility that's needed if you wanted to have some sort of escape hatch. Because we did have, when it came to our transformation language, we tried to create our own in-house transformation language that was like easily templatable, that we thought might work for both use cases, but then someone just came up with another use case that we couldn't support. And so we decided to go with a library that already exists, such as JQ. In this case, we have thought of a WASM resolver, which allows you to use WASM to write your own resolver. However, that WASM within Envoy proxy is still not super well adopted, but it is a possibility, as well as a Lua resolver, which also exists in Envoy. But that's a really good question. Yeah, totally. All right, cool. Looks like I addressed everyone's questions pretty well. Well, thank you so much for attending, and I hope you guys were able to learn something about declarative configuration with GraphQL, or even not even in the GraphQL context, in cloud context, or in any other context, such as ordering pizza. Well, and I hope you enjoy the rest of the conference. Thank you.